Integral applications. In this class, I'll be discussing about the determination of area of a circle using the integral technique or integral application. Let us consider a circle. Let us draw a circle. O is the center of the circle. Let us consider this as x-axis. X dash x. And similarly, let us draw y-axis that passes through the origin y dash. Now, if we are able to calculate the shaded area, that is the one quadrant of this circle, and multiply by 4, we are able to get the area of the circle. Therefore, area of the circle is given by, in fact, we have to consider this curve. Let us consider this curve. So area under this curve means, now let us consider the smallest rectangle with y as the length and dx infinitesimally small difference in the x, that is dx. And let me consider this is A and this is B. So we are considered this curve. So once you are able to calculate the area under the curve, that is this AB, and of course you can indicate the point A. What is this point? That is A dimension, A unit in x-axis and 0 unit in y-axis. What about B? 0 unit in x-axis and B A unit in y-axis, right? And A being the radius, and here this indicates the points, that is A comma 0, that is A, and 0 comma A, that is B. Now let us proceed. The area of the circle, area of the circle is given by, now you have 4 quadrant, 4 into area of the region, that is A, O, B, A, bounded by the curve. So let me say this is the first quadrant. Okay, first quadrant. And so you should be able to clearly define this area. How you can define this area? That is area of the region, area of the region A, O, B, again A, O, B, A. Okay, bounded by the curve, that is AB is the curve, bounded by the curve, right? Now curve is over and you have got x-axis. So comma x-axis, and you have got the y-axis. Okay, so and y-axis. So we have now that is the area, and that is completely defined here. And so once you are able to arrive at this, you can multiply this by 4 so that you are able to get the area of the circle. So 4 into, what about this area of this, the area under the curve, how it is represented? Integral between the limits 0 and a, 0 and a in x-axis. So you can put y dx. So this is the way we can calculate the area of the circle, right? And what about this y? That is equal to 4 into integral between the limits of 0 and a, and this y. What is this y? That is this one. Y is nothing but, that is, you have got the radius. For example, let me identify this as radius. Okay, this is radius. OA is radius. Let me consider a point P here also. That is also radius, and this is also radius. Okay, so you can consider this as A. And what about x-axis? The x-axis is, that is this one. Let us draw like this, and it makes a right angle here. Now you have the x-axis and you have the A, and what about the respective y here? The y is equal to, that is, we know, let me draw this diagram clearly here. Okay, are you able to follow? So this being right angle, okay, you can apply the Pythagoras theorem here. So this is y, and what about this x? What about this one? A. So you know very well, x squared plus y squared is equal to a squared. Is it not? X squared plus y squared is equal to a squared. Now we are interested in y squared. Therefore, y squared is equal to a squared minus x squared. Therefore, y is equal to the whole square root of a squared minus x squared. So we can replace this y by y is equal to the whole square root of a squared minus x squared. So a squared minus x squared whole square root of dx. Okay. So now we have clearly defined the area enclosed by the circle, right? Now we can solve this. That is, let us solve this. So what is the, let me rewrite, area of circle is equal to 4 into integral between 0 and a, and what is that? A squared minus x squared square root 2 of what? That is dx. So we got the formula for this. We can apply the formula straight away so that we are able to get the square root of a squared minus x squared is given by the formula x by 2 into square root of a squared minus x squared plus a squared by 2 sine inverse of x by a. So we have to do it one, either you have to remember this formula, otherwise you have to work out the entire integration. I will tell you later about this. Now 4 into, this is between the limit 0 and a. Now we can apply, instead of a, I can put the final value, that is a by 2 into a squared minus a squared. So this term becomes 0. plus a squared by 2 sine inverse. What is a? X a. So a by a, that is equal to 1. Okay. Minus, then you have to put 0. So when you put 0, 0 by 2, 0. So the first term is eliminated. Similarly, in this third term also, this is eliminated. Now let me have this one. So this becomes 0. Why? Because I'm substituting with the 0 x by 0. So this term becomes 0 plus a by 2. Again, 0 by, sorry, I must replace by x. Replace the x. So a squared divided by 2 sine inverse of x is equal to 0. 0 by a is equal to 0. So put 0. Close the bracket. So that is equal to 4 into, now you have a squared by 2 into sine inverse of 1. So sine inverse of 1 is nothing but, that is, sine 0 is 0, for which value this is 1 pi by 2. So you can have pi by 2 minus, and what about this? Again, a squared by 2. Then sine inverse of 0 is 0. Um, Sine inverse of 0 is equal to 0. So into 0, you can eliminate this term. Therefore, this is gone. So 4 into a squared into pi by 4. You can cancel. Now you are able to get pi a squared, which is a is equal to radius. So area of circle is pi a squared. Likewise, you can apply the integral, and based on that, you can arrive at the area of a circle. You understand this? Now we can alternatively take the horizontal strip also. I will explain. So in this case, I've taken the vertical strip. Now vertical strip means you have got the smallest rectangle with the dx and y. So this is called a strip, a rectangular strip. I have taken the vertical strip. Suppose if I had taken like this, that is a horizontal strip. So this is called vertical strip. This is vertical strip. Now let us proceed with horizontal strip. Let us draw once again the circle, and let us have the quadrant, x-axis, y-axis. Okay. Now let me have the dy as the smallest breadth element. So this is dy. And what about this? This is x. Now let us proceed. And here A, point B. And this is represented as a comma 0. This is represented as 0 comma a. And this is the origin. So let us proceed. So here we have considered, now we have to consider this rectangle, I mean first quadrant, where let me consider this small strip. This is the horizontal strip. Do you understand? Horizontal strip. Now let us proceed. So area of the circle is equal to 4 times of the quadrant. So 4 times, and it is illustrated here as x into dy, is it not? So integral between the limits, that is a 0 a x into dy. In that case, you have to replace the x. We know already a squared plus is equal to a squared is equal to x squared plus y squared. So let us have this x squared, that is a squared minus y squared. So x is equal to square root of a squared minus y squared. So let us substitute the x here. Therefore, area of a circle is equal to 4 into integral between the limit 0 and a. Now you have this a squared, square root of a squared minus y squared of dy. Okay. Now let us apply the formula 4 into, for the whole square root of a squared minus y squared, it is y by 2 into the square root of a squared minus y squared plus a squared by 2 into sine inverse of y by a. Okay, between the limits 0 and a. Therefore, 4 into, by substituting this, final minus initial. So instead of y, you can put a. So a minus a becomes 0 here. So first term is eliminated plus the second term is sine inverse of y is equal to a by a 1. So sine inverse of 1 means that is a squared by 2 into pi by 2, because sine inverse of 1 is equal to pi by 2 minus, again you have to substitute 0. So y is equal to 0 means y by 2 means 0. So the entire first term is cancelled. It becomes 0. Then a squared by 2. So in this case sine 0, sine inverse of 0, because y is equal to 0. 0 by a is equal to 0. So 0. So sine inverse of 0. Okay. So sine inverse of 0 means 0. So this is also 0, cancel. Now you have to consider only this term. Now 4 into area of the circle, area of circle, 4 into pi squared, pi a squared divided by 4. So you can cancel this. Now area of the circle is equal to pi a squared. Okay. So let me summarize. In the first case, this is method 2 and this is method 1. So what is this method called? Vertical strip method. And what about this horizontal strip method? Okay, so in the vertical strip method, you have to consider the vertical strip with the dx as the width and y as the length. In the horizontal, dy as the strip width and x as the strip length. Okay, so based on that, we can easily arrive at the area of the circle as what? Pi a squared, right?